So welcome to the birthday special from my Algos in 10 season 4 episode 7. Can you believe it's already been past almost halfway, more than halfway of the season? There'll be total 10 episodes. So this episode is going to be very unique and very special. For the past year, here in Orlando, I've been moving out from Massachusetts. I developed a new, amazing opportunity to enjoy a new type of hobby called spin cycle, which is indoor cycling. And to give you a preview of what I do for indoor cycling, here is one of my indoor cycle exercises I tend to do. You'll see in the indoor cycle exercise that I have different positions, of course. There are three main positions. There's position 1 or level 1. There's level 2. And then level 3, high and low for spin cycling. Trying to find the video right now to show you how I do spin cycle. There it is. So as you see from this video right here, I do a little spin cycling. So let me actually make my screen a lot more clearer so you can see what's going on. There we go. Now it's a lot better. So here we go. Just doing a little spin. Position 2. Position 3, high. Position 3, low. You can see I do 3 positions in the spin cycle. So for further ado, here's the episode for the birthday special. I am turning 28, which is pretty amazing. So for the episode tonight, we got quite a few interesting things to go through. So it's called Spin Cycle Birthday, and this episode is dedicated to 24-hour fitness spin cycle. And also for my B-Day. So according to, the old baddies meme from Jordan Poole and NBA, honey, see you spin cycling. For the first time in my 20 years of existence on this earth, I found a sport that rivals basketball and aerobics and just plain good old fun with the music mixtapes and stamina, spin cycle. I've done hiking in Boston. I've done some canoe rowing here in Florida for Lake Pickett. Yet nothing gives you the thrill than being able to turn that knob to max resistance and just spin your heart out. So all of the parts of the episode are based on spin positions, which I mentioned level 1, which is you sitting on the bike, level 2, which is you basically crunching over the bike, standing up. Level 3 is high crunch, and level 3 is low crunch. Let's tone some muscles and start spinning. So for part 1 of the episode tonight, we have Big Country and Little Spin, which is the first ever LeetCode for the databases. And enjoy it like I would with my cake for portioning episode out Friday. So this LeetCode is really simple. There's not much to it. It's really just a nice little logical statement question. So I'll show you guys the prompt, but I won't show you the answer because I want you guys to think about it for a sec. I'll give you exactly 28 seconds to think about it. And by the way, for those who know hex very well, what's 28 in hex? Let me know in the comments. And also, it's very important that I will actually not be doing any more Algos in 10 next year because I think I need some time, with the mental health and just working on some other cert work. And I think, just think about new things in terms of my life. So I'm hiding away the solution so you guys don't see what's actually the answer. So here you go. So in SQL, the name is the primary column for table. You will find basically if a country is big, if it has at least an area of 3 million, or has a population of at least 25 million. Find the name, population, area of the big countries. So here's the schema for the SQL. If you've never done SQL LeetCode, it's actually quite good. It actually gives you a lot of very good, very solid querying questions. For me to get this Opting UHG job I have right now, even from Dell and my corporate BCH, I had to do a lot of SQL, a lot of querying data and analytical questions. So LeetCode has this very new feature that has SQL in it. So you guys exactly 28 seconds to think about the SQL. And while you do, let me talk about something that's very important in regards to why I'm taking a break from Algos after this year. Mostly mental health. I know like sometimes YouTube, and these hobbies can get idolatry, could really take over precedence of what's really important, which is of course the Lord and my partner and family stuff. And sometimes it's really hard to like keep on like making episode or portioning like cooking stuff. And I see from the recent YouTuber Facebook and a bunch of people just burning out as well. And I think it's important that people need to take some time, some break from these type of things. So yeah, I'm hoping that after this episode and after this year in general, we can learn to just give our mental health a bit more respect and a bit more importance. So give you guys like 28 seconds to think about this problem. And also very important, you can return the result table in any order. So if you have SQL query, run up on my SQL or run up for something good. If you don't, just think about the pseudocode, the select from where and other stuff. All right, that's 28 seconds. Let me show you guys the solution. So you do a select name population area from world where area is greater than 3 million or population greater than 25 million. There you go. That's basically a solution. And if I run this thing, it should pass the test cases. Now, I didn't read the question carefully at first and got it wrong. That can happen if you're under time pressure. So be careful reading questions. I submit it and it should be all good. Yep, there we go. Memory is very good, the solution. So back to the episode. You have some, 3 very basic, or at least straightforward problems that have recently been my highlights regards to July. So first one is called the Kadane algorithm, which is to find longest contiguous subsequence, in this case, amount of people for spin. It's called Kadane spin twist. Problem 2 is the subset sum cooldown. And yes, problem 3 is dynamic programming, but it's actually quite simple. It's basically double application of Knapsack. So before I show you guys the solution for each one, let me just give an illustration of what's going on with the first problem. Go back to the old whiteboard. So in this set, we have something called 2 arrays for spin. We got an array for people and an array for exercises. So you got 2 arrays, people array, people in the spin class for 24 fitness, and the spin exercise you do for spin. You have people, from set P1 the p n minus I, because you have n I index all the way to the p of n. And exercises, you got something pretty similar. You got something pretty similar. You got exercise S1 all the way to S of m minus j, or S of m. Now n and n could not be the same. So what we want is an algorithm to basically determine, using Kadane's algorithm. Now Kadane's algorithm trying to find the longest contiguous subsequence. So for example, we have something like this going on. 3, 4, 3, 4, 5, 6, 1. Kadane's will give me 3, 4, 5, 6. So that's Kadane's algorithm in a nutshell. So how to begin with thinking about this problem? I'll have 2 pointers. So I need to draw a pointer variable here. So I have 2 pointers. I call this pointer pointer P for people, and I call this pointer S for exercises. So we also have another pointer, which is going to compare to this pointer, max so far. So this is a really basic application of Kadane, but it gets interesting in terms of like an edge case, where you have all the people failing to do exercise with spin. That's when my instructor basically says the class is over, see ya, good night. So max so far P is one of the ones I have for pointer. And also another point I really think we should take care of is max so far S. So that should be a very simple illustration in regards to how to make the algorithm. And as for the pseudocode, I'll let you guys think about the solution. I'll reveal the solution in approximately another 28 seconds now. Just think about how you apply Kadane's algorithm. How do you update the pointers? And most importantly, this is a really tricky part. How do you determine what is max so far P and what's max so far S? I'll give you a hint. Max over S, at the worst case, is the last guy doing exercise before spin we do cooldown. So it's like, the last guy in the array, or last element in the array. You guys another 28 seconds to think about it. Oh, by the way, the contiguous algorithm can have duplicate elements. That is a possibility. All right, so let me show you my coding solution for it then. So here's my coding solution for the problem. Very, very simple, hopefully. If you see my screen, here's my coding solution. So the coding solution should be pretty straightforward. You have spin Kadane with 3 variables, array, P, which is the people pointer, S is the exercise pointer. So basically the pointer is 0, nobody's done exercise yet. S is 0, no S has been done. Or len array is 0, len array or array is none. The very basic base cases, return 0. Also, you have 2 pointers. You have max so far P, which is max array. Max so far S, which is len array. And then for I in range P minus 1. They want to do P minus 1 because they want to get array out of index. Current equals array of I. And S equals the max of either the current pointer or the current exercise has been done for the pointer. And for J in range I plus 1, comma P, because you want to basically have the pointers intersect each other. You have current array plus equal array of J. So you have to make sure J and I are not intersecting each other in the algorithm. This is a very important conditional as well here. If current pointer is greater than max so far pointer, you reset the pointer, and you basically run the main. So here's a very basic test case I have here. Largest contiguous subarray, you have 4, 5, 6, 1, 7, 8, 9. You want to find the largest contiguous array of people doing the exercise correctly, and you run the spin. And you basically set it for 5 exercises. If it's anything set to 0, or if array is none or is null, then it's going to return 0. This is the worst case. Everybody else screws up. Only the last guy did everything right. This has actually happened in 25-minute spin before. This has happened. And of course, a dream situation or best case, everybody does it amazing, and everybody does the spin correct. Without further ado, let me just run the algorithm on my terminal now. So there you go. So max number of exercises complete is 8 for first case. Largest contiguous subarray sum is 50, is adding everybody up. The second case is 0, as I mentioned, the nulls. The fourth case is 100 because everybody is doing a wrong except for one last guy. And then, of course, 55 is basically add up 1 to 10 as summation. So if you have any more questions for Kadane algorithm, I suggest you go on YouTube or Wikipedia to search for it. That's for part 1 of the problems. So back to the episode itself, part 2. This is an interesting problem. Part 2. Subset sum with cooldown. So it's time to cool down, my 24-minute instructor says. The cooldown often comes with some stretches, some basic stretches, like this type of stuff, really. Some basic stretches and basic slowing down the intervals. So given RPM intervals of following 70 rotations per minute, 60 rotations per minute, 50 rotations per minute, 45 rotations per minute, down the road, come up with a recursive algorithm. It should be recursive, that runs O(n) time to get the subset sums of each shortest RPM interval. So now to give an illustration what I mean by this, I have something else for the whiteboard. So I'm going to clear this thing. I'm going to save this thing one last time, then clear it. So for this case, I'm going to have the following. I'm going to have only one array this time, keeping all the RPMs. So this is the RPM for all the arrays. I then have a subset of an array. So, S1 ... SM. Array indices, which basically represents, the cooldowns. I have A1 ... AN. I have a cooldown array here, which has already been determined by RPM. I have, 70 RPM, 60 RPM, 70 RPM, 60 RPM, 50 RPM, 45 RPM, and then before we basically stretch and call it a night, we have 30 RPM. So you want to find a recursive algorithm to determine what's going on here. So one way to do it is the following. Case 1. If the sum is 0 or array has nothing, return 0. Case 2. If the subset is none and sum is not 0, return -1 because you can't find anything. Else case 3, if the last person in cooldown has RPM greater than the sum and the cooldown is non-negative, then recurse on the previous person. So far, this is making a little bit more sense. With recursion, it's very basic, very straightforward stuff. And now I have the recursive case. Recursion on each of remaining cooldown RPM. So this means you basically have cooldown subtract by 30. So then you have, cooldown subtract by 70, 60, 50, etc. To give you guys another 25 seconds to think about the recursive solution for this process, I'll give you the answer. So once again, give you 28 seconds to think about this. Oh, by the way, if cooldown is negative, this algorithm will not work. And the runtime should be OM. We're just going through like a linear recursion, sort of like a count sort type of thing. Recursion sort through all the RPMs. Recursion can be tricky, so think about edge cases carefully for this problem. All right, time's up. Let me show you my solution. So here's my solution for the algorithm. Now, yes, terminal does sometimes give you the spinning ball of death, unfortunately. That's okay, guys. So here's my solution. So I have a main function called step spin subset sum array s, which is so far the desired short spin interval before cooldown. I have the sum, which is current subset sum before cooldown, and of course cool, which is the cooldown speed. So as mentioned in case 1, if sum is 0 or array is none, or cooldown is negative, or s is 0, return 0. Case 2, if it's 0 and also sum is not 0, return -1. Recursive case 1, cooldown's not happened. We basically return everything regards to cooldown minus 30 because that's the lowest number cooldown plus s. Recursive case 2 recurs basically in everything. Recurs on 45 RPM, 50 RPM, 60 RPM, and 70 RPM. And the test cases are pretty straightforward. You have the best case, which is like, an array here, a sum of 10. And cooldown should be not negative. You never have a negative cooldown in real spin, so it returns you 0. Here it gives you 1, because it's only giving 1 cooldown at a time here, which is the best case scenario is like 10, 20, 30, 40, 50. So it should give you 1. This is a real life class scenario. You have maybe somebody spinning 100 RPM, going really, really fast. There's somebody basically just not, giving a damn and like spinning low on 30, and then somebody under Instagram, showing off whatever and under 50. Like the point is, it gives you 15, because basically only half the class has a subset sum equivalent to cooldown, which is 200. The 130 guy probably spinning like crazy, plus 70 guy, or the 100 girl plus the 50-50, like girls. And this is the worst case scenario. This has happened before in spin. Everybody goes way, way too fast, and then they basically end up having like a bad circulation because they couldn't stop like, spinning in time. It only gives you one person because it only gives you one again because only one person can cool down at a time. This problem is actually relatively easy if you think about it in terms of recursion. If you don't, though, there's iterative solution, and let me tell you, it's the reason why I don't use it, because it requires a little dynamic programming. And just like a birthday cake, it will not taste very good, or the problem will not be very easy to solve if the cake foundation or the foundation of the problem already is too complicated. That being said, part 3 will require dynamic programming. So I'll give you guys some time to think about the way to solve the problem while I share the problem with you guys. So the third and final problem for this part of the episode. Now, I've been to the wetlands in Christmas, Florida, with some friends locally here in Florida. And one really crazy thing I saw was a big gator against a stately Florida bird. And I'm going to show you guys the battle of the gator and the bird. Meet my friend Maddie and some people from church. We were excursioning a gator. Here we go.
There's a lot more of us than this gator, though. Not fair. Whoa.
Yeah, the gator got scared. The gator learned a lesson. And you know, the wetlands giving you Civ 6, Celtics vs Heat, DRs versus T1 League of Legends 2022 Finals or Worlds, which is why I play Spin Walkin by Lil X Nas for the outro of this episode. And my partner and I made idolatry run for his money. We're looking at the mighty Florida Gators versus the stately Florida State Birds. And this is like double knapsack. So each gator has a set of G steps to take, with I steps of threats, which means they basically get attacked if they get caught attacking a bird. Likewise, each bird has B steps to take back, with J steps of threats of being simply eaten by the gator. Come up with a dynamic programming knapsack-like solution that runs less than O(n) squared time. And of course, for them animal lovers, if Peter doesn't cancel my YouTube channel, no gators or birds are actually harmed in the making of this episode. So I give you guys now 56 seconds to think about this one, because it is a DP problem, it's a damn programming problem. So 56 seconds to think about this one, almost a whole minute. And while you do, I'm going to set up the dynamic programming procedure to solve this problem. As you recall, dynamic programming is about the English statement. This time we have two English statements. You have one for gators, one for birds. You have two Bellman equations for the gator and the bird. You have a proof of runtime for both gator and bird. And of course, very importantly, don't ever forget this step or you will get a 0 in your algo exam and fail LeetCode, the proof of correctness as well in terms of runtime. So 4 main steps, I'll show you all the steps in general pseudocode. Then I'll give you the really tricky to code, but very rewarding to understand solution. And that'll be it for the part 2 of the episode. So I'll give you 56 seconds to think about it. And by the way, if you have actually any trouble with dynamic programming, I suggest you look over some resources from Udemy or even from LeetCode, or just look over the general stuff. Over the years, I've actually started to appreciate now solving algorithm problems, now no longer under pressure with solving always under IT interviews and stuff. I realized it's actually quite useful to understand problems when you actually apply it to real life context. And that's all the point of Algos intent. It's not to flex how much I know LeetCode or flex my partner or anything. It's just like, it's not even idolatry. It's just like trying to understand why these problems came to be and how to solve them in an efficient, non-mentally stressful way. Just like making a good cake, you need a foundation, you need the right stuff. A good algorithm has the right foundations. So here we go. Here is the final screen share I'm going to share for the Algos intent episode. So I'll be saving this. I'll be full screening this whiteboard because it is going to be a lot of work. So I'm going to be full screening this for the whiteboard now. We have a dynamic programming solution for gators versus birds. Because this problem is really loosely based on knapsack, we need to draw something here. Now, as you recall, the knapsack problem for dynamic programming is like the following. You have a knapsack, you have a bunch of items, you have a bunch of items with value. You basically want to get the smallest amount of items with the most value in your knapsack. If you add too many items too heavy, the knapsack will be too draggy and you'll probably end up breaking it, or end up breaking it back potentially. Like how back in BU Northeastern, I basically had issues with those heavy ass textbooks and like those crazy, like crazy school supplies. Now at work is the other way around. I have almost nothing to carry around at work because I work from home remotely. But mentally, I have a lot to carry with regards to solving problems and war rooms and stuff. So we got the following. We got an array of gators and birds. So we got a gator array. We also then got a bird array. And each gator and bird array has threats to their habitat. So gator and bird have threats to their habitat. So you have basically, threats here, or steps to avoid a threat. You have threats here. And for birds, you also have steps to avoid getting eaten by gator, and steps to avoid threatening by gator. So let's say, for example, it's me and my friends in Florida, or somebody visiting, and we're talking about gators. Let's say gator steps 2 steps away, then realize the bird is very close with my friends, only takes 1 step, and then dude's like, uh-oh, I'm gonna get like probably canceled, attacking a bird, unlike Lizzo tonight. So then you have 3 steps coming back. So the threat level would be probably 0, because the gator thinks he's all good, he's all Gucci. Then 1, uh-oh, the gator might actually get canceled or attacked because he doesn't want to get eaten, or he doesn't want to get attacked, basically. And then of course it'll be 0 again once he basically retreats. As for the bird might be a little bit more daring. The bird might take 4 steps, in the beginning. And then he's like, oh no, I need to go back, and then, go back again, and then avoid the gator. So it might take 4 steps, because the bird is small, it takes more steps than the gator. He might take 5 steps and then finds the gator, but eat him. And then he basically, retreats back. And for the bird, the threat is basically not going to be existent because he's always far away from the gator. So 0, 0, 0 for the bird. If you're thinking, Jason, what are you talking about with gators and birds? It relates to Knapsack because you want to basically make a decision on whether you keep the item, or in this case, you keep the step, or throw it away to avoid threats, which is the steps is analogous to the item in a knapsack. The threats is analogous to the value of how much threat to the value the gator and the bird will have. So in terms of English statement, here's the first one for the gator. I wrote this down in advance so I don't write gibberish. Given G amount of Florida gators in the wetlands and I amount of threats if gator GI attacks a Florida bird J, we can include up to GI plus GJ amount of gators that are not under threat. That's the English statement for dynamic programming for the gator parts. Given G amount of Florida gators in the wetlands and I amount of threats if gator GI attacks a Florida bird J, we can include up to GI plus GJ amount of gators that are under threat. So think about how will the English statement for the bird go? It should definitely be the opposite, right? Because the bird trying to get away from the gator. So for the bird, it's like given B amount of Florida state birds in the wetlands and J amount of threats, if bird B of J gets attacked by Florida gator I, we can include up to B of I plus B of I minus. Now you have to be careful here. The bird's saying, wait, B of I minus B of J amount of birds that are not under threat. So it's like a dual of each other. It's almost like the opposite of statement 1. So there you go. That's your English statement for the DP. So the next step is, of course, Bellman equation. That's very important. So let me clear the work, and let's include the Bellman equation. So Bellman equation number 1 for dynamic programming, which is going to be gator. And if you get the Bellman equation, you pretty much can code this thing out solution-wise for this thing. You have a gator function. We have T, G, val, and n. So T is of course the gator steps. G is the the weight of the gator step. Val is the value, and n is the number of steps that could be threatened. So here's how it goes. If n is 0, and if t is 0, you return 0. And I'm gonna make this a little bit easier to read, so bear with me 1 second. If g of n minus 1, which is the last time the gator takes a step before being threatened, is greater than t, then we do recursion on gator g t val n minus 1. That's like general knapsack. And now, of course, we gotta be very careful with the recursive case. So recursive case basically find the max of the value of n minus 1 plus the gator function, which is tg of n minus 1. You try to find the previous gator being attacked. G val, sorry, it's t minus g of n minus 1. So you can see this is really hard to conceptualize without like programming here. They have g val n minus 1. Either the max of that from the gator that has not been threatened or the gator that will have been threatened, gator t of g of val and then n minus 1. It's the same thing as basically before. So that is the Bellman equation for the gator. As you recall, the bird is a dual of the gator. So you want to be very careful here. So for the bird, which I'm actually going to change color now to be red to make this a little more interesting. Bellman equation 2 for the bird. They have a bird function, this time with HB val n, analogous to basically the total threat to the bird, the total weight of a bird, the weight of each step for the bird, the value, and of course, and the number threat. So same as before for the gator, n equals 0, h equals 0, return 0. You can see Bellman equations are very simple to figure out once you actually understand what's going on with the logic. If you don't, though, it's a nightmare. And that's why LeetCode dynamic programming is so hard. You have to think in multiple ways of logic. Otherwise, if now b of n minus 1 is less than h, because the bird's trying to avoid the gator, you want to do recursion on bird. H, b, val, n minus 1. Otherwise, finally, for the bird recursion, you do a max here as well. So it's not a min because although it's same as a dual, you still have to maximize each knapsack for the gator and the bird, how much they can take a risk for. So it's h minus, of course, there's h, so it's basically the same as before. It's val of n minus 1, of course, plus the bird of h minus b of n plus 1. The bird trying to get away from the gator is the dual of the gator. B val and then n plus 1. Or you have the bird function again of h, b, val, n minus 1. So basically attend the bird. Do they want to be eaten or not want to be eaten in terms of recursion? And there you have it. That is the Bellman equation for the recursions. All right, moving on to the proof of runtime. I'll make it back to regular blue. Or whatever, proof of runtime. So proof of runtime, for each loop, we have basically O of n for gator and O of n for bird. For the recursion, it should be constant because we are doing work only on yes/no decision for gator and bird threat. For the memoization or the store, we're doing O of m or O of n because we're doing for n gators and n birds. So final runtime will be O of mn, which is very much going to be less than O(n) squared. So there you go. That is the final runtime for the recursion. And we're not done yet. We have one more runtime thing. So final runtime, proof of runtime. So we have one final thing called proof of recursion. So for recursion for dynamic programming, you want to make sure that it's O of m times O of n for each one, which is O of mn. and less than O(n) squared. That's it. That's your proof of recursion. And there you go. That's your dynamic programming in a nutshell. So let me show you the code for a solution, and we can move on happy. Oh yeah. The dynamic programming is interesting. So we have the solution here for the code. You have a coding solution for problem 3 using Knapsack as basis for dynamic programming. We've shown the English statement for DB for dynamic programming. We showed the Bellman equations, as I mentioned before. We show a proof of runtime. I made a typo, actually. It's n+1. My apologies. I made a typo in my other corrections. So it's a little bit of a nuanced thing. We also show proof of runtime and show final runtime as well. So we have a knapsack gator with T, G, val, and N. We do a memorization array for each, each part of the gator being threatened. We do 2 for loops, one regards to N, the number of times the gator could be threatened, and T, the number of weight the gator gets threatened. We go for the 2 recursion cases. If I is 0 or k is 0, return 0. If recursion case 1, we basically choose that the gator did not get attacked. So we do the first case, otherwise recursion 2. If the gator did get attacked, he goes back by 1. So the elif statement is really tricky if you don't draw like an example. So recursion is very important to draw with examples. The bird is a dual of the gator. You have memorization array, you know, the same thing here. And here in the bird, it gets very different. You have a different variable in terms of the difference. You have b of j plus 1 less than k. Back for the gator, j of I minus 1. So this is a very subtle difference. This is the worst case that the gator and the bird are almost about to attack each other, but they're not willing to make another move to attack each other. And they both end up, you know, saying, GG, we're not going to cause a fight on National Geographic or Florida and get put on, you know, social media over gator and bird cancel culture. Like, the point is the gator and bird don't want to fight it out. They rather pray it out, and they rather just go back to their respective places. That's when we decided to give the bird another opportunity to retreat. Otherwise, the bird will get eaten if he doesn't move. So long story short, this is the most important part of the entire solution. Is use 2 very important functions. And to do runtime for this, we have the following. So I don't have any base case or recursive case proof of correction. If I were to make test cases for this DP, I would definitely choose null cases. So always start your test case with null. What happens if nobody moves? What happens if bird doesn't want to even talk to a gator? What happens if gator just simply says, screw it, I'd rather eat fish and not care about the bird? It's just like a birthday cake. Do you want to blow the birthday cake now or blow it later? Dynamic programming is all about making decisions based on logic and based on how much memory you store. And sometimes it can get very tricky. So this is a really good example of illustrating why you have to follow the steps of dynamic programming. If you don't do it, you're going to get the problem wrong. Now, with that being said, we have one final part of the episode. So hold on for a minute. I'm not done yet. So this is the So I made this a priori, basically, in regards to episode. So, sorry, I was muted before. So let me re-emphasize. We're in part 3 of the episode. We're now in the spin walking part. So this is a handout I made. The main purpose of the handout is to document steps for Azure provisioning and database management, some of my favorite 25 famous spin songs and some of the famous moves. And these songs and moves are given express permission in terms of copyright. So setting up Azure provisioning is in this link, which we click on, and we should be able to get to the link of the episode. So this is the thing about Azure provisioning. Make sure you keep track of all your credentials, your username, your password, your resource group, and your server name. If you don't do that, you'll have a very hard time completing this module. That's all I'm gonna say for that. Going back to the PDF, once we have set up a provisioning, we can have, the spin Walkin. And have the top 10 most popular spin songs. And let me show you a demonstration of that for my spin Walkin Azure solution. So basically first show DB connection string for spin Walkin. I then, show my password, which is obviously not something I want to show in public, but I'll show just for demonstration purposes, and my username with the SQL command line. And this should basically give me my databases here, hopefully. Yes, awesome. So then I do select star from sys.tables and do a go statement to see what I have. So I have two main things. I have songs. So I have two main things. This command will not work because, it gives you everything, which is not what you want. Instead, you want to do following. You want to select name from sys.table. So follow instructions from the Azure as well. There you go, move and songs. So if I do, for example, select star from songs, I get exactly the stuff I had from the handout. I have the first one, Star Walking by Lux Nas, Calm Down by Rema, Blinding Lights by The Weekends, Wolf by Selena Gomez, Die For You from The Weekend, All the Lights done, dun 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 dun, Kanye West, Just a Dream by Nelly, Pitbull's Hotel Room Service, and all the way down to Britney Spears and Oops, I Did It Again. No reference to Victor Wembanyama and the Summer League. If I want to see how many songs there is, I could do a count statement. So select count star from songs. So this is the beauty of Azure provisioning database. You could basically run queries without having to worry about server. And you can see there's 10 songs counted total. And now if I want to do the other thing, I want to do select star from moves. That would be another database solution I have. And I do click go. I have all the moves. So basically, my 25 fitness instructor tells me that I have, flat road beginning, spinning at like a flat road. You have move be 10 minutes long, duration is only 2, then go up a hill and spin, 15 minutes long, intensity is 3. And basically go for reverse hill, 20 tens, one position, then 10 another. You have endure, and then finally the hardest one, complete hill, which is just like spinning until you run out of resistance. Sprint motivation, a really crazy Eric Lewis type of motivation video, then cool down, then stretch. And you also want to know how these work, count star from moves. So select count star from moves as well. And there you go, that's the moves from the spin as well. So one thing I do notice, if I exit again, I will do the following. AZ SQL DB list, I list all the databases I have, and this gives me a JSON, a JavaScript object notation object. I've also do this and pipe it. And for system programming, pipe is really important, understanding the difference between like some of the logistics here. So you could do pipe JQ, which is, a register from assembly of, shortened version of less than. So it's basically pipe less than symbol name of dot name max size bytes, which how much the database is using in terms of storage, max size bytes, And you want to make sure you have a dot for each variable. That's how Azure DB querying works. And a status and then dot status. And yeah, there's an issue with the way I ran this thing. So I gotta be very careful with the pipe within this thing. Because I didn't use the correct command. I didn't use that. It should be Azure SQL database show -- name spin Walkin. There we go. So we have spin Walkin be the name of my database. Max size bytes be about 1, 2, 3, 4, 5, 6. Okay, about like 3 billion bytes, or about maybe 3 GB or something. And the status is be online. If I go to my Azure utility server, I basically have this thing, and I have overview for my Azure server. Azure will charge you if you don't clean your server. So I will show you guys how you do that in the episode. You delete your database and you delete your server. I'll be doing that after my B-Day, but just a FYI. I have resource group Azure JL321. I have a stats available location East United States, but I'm in Florida. I have one subscription for Azure, the ID. I have, myself as server admin. And all these, really cool Azure, resources and provisioning is very helpful to help you learn about provisioning database work. With that being said, that is it for the episode. So, portioning with Jason, which I'll be making my own B-Day cake and sharing with, some friends in Orlando for Sunday, will be very important. So, as I mentioned before, Algos S5 will not have season 5 next year, at least for like the first half of the year, given I need to break for mental health and cert work and other stuff. But it's been a real pleasure. I just want to thank everybody, supporting me in this YouTube channel. And honestly, with recently some stuff been going on with like, Lizzo and other things, I absolutely abhor those type of practices. I always believe, and my partner as well agrees, that we should always keep anything we do for the Lord's grace. Like we do, algorithms, spin, basketball, following the Boston Celtics, cooking, whatever. We do it for the Lord's grace. And this is why it's very important that we don't lose sight of our goals when we do these type of things. So that's the reason why I always try to be a responsible YouTuber. I don't ever post stuff that's inappropriate or misconducting or anything that my grandmother or my boss would not want to see. So this is a takeaway point. Just like the Gators and birds stuff, you want to make sure that whatever's happening in your life, that it doesn't become a threat. If your mental health needs help, address it. Just like a birthday cake going bad because somebody did not frost it well. Make sure you have the cake layered properly before you add the frosting. Same thing with mental health. Make sure your mental health is all good before you add in some frosting, like partners or jobs or relationships or, those type of things. With that being said, it's time for me to now finally go to sleep. And I enjoyed doing Algos S5 with you guys, and hopefully my birthday will go very well. So yeah, like and subscribe, and thank you very much. Bye.